Hello everyone, I hope you all are good and you all are practicing problems. Let us for now focus on this one, and this is going to be very interesting question because we don't have to do much, we just have to analyze more, understand more. Okay? Conceptually, we have to get at this question in order to solve. So what is said in the question, there is two such sort of let's say there is two such sort of structure. Okay? So they are at 90 degree to each other, and then there is one bead over here and there is another bead over here. Okay, and these two beads have equal masses. This is m and this is also m, and this distance from this corner is d, and the distance of this one from this corner is how much? This is also d. No, this is 2d and this is d. Okay, and this is frictionless non-conducting rod. This structure that I have drawn is frictionless non-conducting. Okay, initially beads are held at rest, so initially they are at rest. Okay, and they have unlike charges. Let's say they have this have a plus charge, this has a plus charge, and this has a minus q charge. So they have unlike charges of modulus q1 and q2. Okay, so this is q1 and let's say this is q2. So they're held at rest initially. So there must be some external factor responsible for keeping them at rest. And it is said that when that external factor is removed, yani ki when the system is released from rest, what is happening? Uh, they will start, moving, sort of, right? So we are asked, when one of the beads reaches the corner, where will the other bead be? Treat the beads as particles. डन है सो देखो हमें मोशन को केयरफुली एनालाइज करना है सबसे पहले आप ये सोचो कि सपोज कर लो ये स्ट्रक्चर नहीं होता वट एवर स्ट्रक्चर इज दिस बेंट सेप्ट स्ट्रक्चर if it is not there and simply this mass is here and this mass is here, this has a charge of plus q1 and this has a charge of minus q1, both have same masses and they are held together initially by some external factor at rest, and when they will get released, in which direction they will start moving. तो आप बोलोगे मैम क्वेश्चन बहुत सिंपल है. Under mutual electrostatic force they will start moving towards each other. Done है? And since if you talk about this system, what is this system? This system has a mass of 2m, right? And there is no external force acting on the system. If we are taking this two masses as a system together, then this electrostatic force acting is a thing of internal affair, right? So there is no external force acting, and if there is no external force acting, center of mass position will be fixed, right? So initially center of mass position will be where, let's say initial separation between these two was L, so center of mass must be at a point L by 2. So this will start moving in this direction, this will start moving in this direction, such that their center of mass will stay fixed, and if they meet, they must meet at this point only, because then only center of mass will stay at this position throughout the motion. डन है. बट यहाँ पे क्वेश्चन थोड़ा सा डिफरेंट हो गया. डिफरेंट इसलिए हुआ बिकॉज वी आर कीपिंग इट इन अ स्ट्रक्चर इन ऑर्डर टू ऐड कंस्ट्रेंट टू इट्स मोशन, राइट? क्योंकि ये जो स्ट्रक्चर है ये इसको लिमिट ही करेगा. इट वोंट लेट इट मूव along this direction, right? It will let this thing move along this line and this thing move along this line. But still, force acting is the same, right? On this charge particle, force will act in this direction. On this charge particle, force will act in this direction. Equal and opposite, right? अब देखो यहाँ पे हो क्या रहा होगा. So this force will have two component, one along the structure and another perpendicular to a structure. So force that is perpendicular to this structure is somehow getting balanced by this structure effect, right? So this structure must be applying force on it in this direction such that it is keeping the bead in rest along this vertical line, right? And it is then constrained to move along this line. ओके, सो इस क्वेश्चन में हमारा सिंपल सी चीज ये है कि वट एवर ग्रेविटेशनल फोर्स नॉट वट एवर इलेक्ट्रोस्टैटिक फोर्स इज एक्टिंग ऑन टू बिट्स, ओनली देयर components along the structure will help them in move. So if this is the bead, electrostatic force acting in this direction, so let us draw it here. Suppose कर लो initially this bead was here, ठीक है? So यहाँ पे this was the force का direction, force initially, and this was the force initially on that bead. Okay, so if you calculate their, let's say this angle is theta, so in this direction force is F cos theta, and in this direction on this bead, force is F sine theta, right? Because if this is theta, this will become 90 minus theta, and F cos 90 minus theta will be F sine theta. So these two forces will, apply force on these two beats. I mean, force तो पूरा ही लग रहा है, Fe लग रहा है, but two are getting balanced. I mean, this vertical component is getting balanced by something that we don't need to focus on here. ठीक है? So what is assisting in the motion? F cos theta and F sin theta. So now if you talk about their center of mass motion, we cannot say their center of mass initially, which is at this point, will stay at this point. No, because now external force is acting, right? इस structure का force लग रहा है, which is balancing this thing. Done है? So external force is there. We cannot conserve the position of center of mass. Okay. So now we need to talk about कि center of mass किस direction में move करेगा. And center of mass will move in which direction? In the direction in which ACM will be. So acceleration of center of mass will have, what direction? So अगर आप सेंटर ऑफ मास की बात करो, देन यू आर टॉकिंग अबाउट एम एंड एम टुगेदर, राइट? सो टू फोर्सेस आर एक्टिंग, एफ कॉस थीटा एंड एफ साइन थीटा, एंड दिस एफ कॉस थीटा एंड एफ साइन थीटा विल हैव रिजल्टेंट इन विच डायरेक्शन? क्योंकि देखो इनका जिधर की तरफ जिधर रिजल्टेंट होगा, in that direction only net force is acting on the system, and in that direction center of mass will move. So if you calculate carefully, this is your f cos theta and this is your f sine theta, and resultant will be somewhere here, such that let's say it is making an angle, this resultant is making an angle alpha with the x-axis direction. Okay, so if this is alpha, आप alpha को easily निकाल सकते हो. Alpha को क्या लिखोगे? Tan alpha you can write as f sine theta by f cos theta. So it is interestingly equal to tan theta, so that is alpha is equal to theta. कहने का मतलब ये है कि यहाँ से जो फोर्स का नेट फोर्स का जो डायरेक्शन है, दैट इज इन दिस डायरेक्शन एंड दिस एंगल इज हाउ मच? थीटा. ठीक है? सो दिस एंगल इज थीटा एंड अलोंग दिस लाइन इट विल दिस body will move. Okay, so if this body is moving along this line, where will they, if the question is that one bead is at the corner, where will the other bead be? Done है? So I have said you this is the direction of net force acting on the bed. That net force because of which motion is happening. Okay, so this is this. So if net force direction is this, at any moment center of mass will be find at on this line, right? So center of mass you will find on this line. Let's say one of the mass is over here, one of the mass is over here m, and let's say I'm telling कि चलो दूसरा mass अभी यहीं पर है. तो अगर ऐसा होता है देन सेंटर ऑफ मास विल बी हियर, लेकिन ये नहीं हो सकता, राइट? बिकॉज सेंटर ऑफ मास विल लाई ऑन दिस लाइन, इट कैनॉट बी समवेयर एल्स. डन है? सो इफ वन मास इज एट द कॉर्नर, अनदर कैनॉट बी ऑन दिस लाइन. सिमिलरली अगर मैं कहूं कि चलो ये मास पहले कॉर्नर पे पहुंचा एंड दिस मास इज समवेयर हियर, अगेन सेंटर ऑफ मास यहां होगा. अगर ऐसा होता है तो, बट अगेन दिस इज नॉट पॉसिबल, राइट? बिकॉज सेंटर ऑफ मास हैज टू बी ऑन दिस लाइन. And for that to be possible, there is only one case when one bead is at the corner, another bead also has to be at the corner. ठीक है? So दोनों bead जो है तुम्हारा corner पे simultaneously they will reach over here. And this is very interesting result, right? So simply from the motion of center of mass, you can trace कि यहाँ पे क्या हो रहा होगा. I hope you have understood this question, but if you have doubt anywhere or if you have anything to say, you can always let me know in the comment section. Thank you. Take care of yourself. Bye bye.